Okay, so usually when I start off the meeting and say, I've done absolutely nothing again this week, and I've done that for several times. Now, the meeting last week, I was saying, I was thinking I could take the Pure Pursuit program, the one that's the Lyrics Pure Pursuit, that's the one that is on the official original ROS1 wiki, and that does some fancy calculations and makes your vehicle drive around. You give it a path, and this thing is supposed to follow the path and drive around. And both I and Al have played with that. And if we put it on the simulator, it works just fine on the simulator. But on his lawn tractor and on my little mini tractor, it doesn't seem to work. It won't stay on the line. It kind of oscillates back and forth. And I was saying in the meeting last week, I could probably just say take the vehicle location. So you've got base link representing your vehicle location, and say it's right here in the world, and then your path you want to drive to is up here. If I just simply say take the heading of the vehicle, which is say this way, and then the path is going this way. If I just draw a line from this point up to this point, and then say figure out what the angle of that is and compare it to the angle of my heading that comes out this way. If I just drive those two down to a difference of zero and drive towards it, that should drive to the point without all this extra monkeying around that they're doing. And I thought, well, I should do that. And then, like a couple days later, I actually sat down to attempt that, and I put some code in and put it on the simulator. And much to my surprise, that does actually work. So I was running on the simulator, and it was giving me some fairly decent results there. So then I thought, what I need to do is take it out and put it on the real lawn or the real robot. And my robot's about half the size of Al's lawn tractor, and it's got an electric drive on it. So anyway, I put the code on that and took it out to run it. Anything interesting in between there? And then I loaded the code on that computer. I took it outside and put it in the yard and drove the standard path that I always do. Let's see, how can I get that to come up? I have to say share screen, say screen 2, and I have to go to my hidden windows here. I think this is the one. No, that's not the ones I want. I want to go to this one. Come on. So I took it out and drove it around uh, on my vehicle using that same code. It does this where I always start down here in the lower right hand corner, and the vehicle is pointed this direction. It's pointed north. And then the first point of the path is right here, and it's pointed west. So what happens is when you start up Pure Pursuit, it's supposed to say, okay, um, it, it it's got an array of points, and the first point is right there. And Pure Pursuit says the vehicle's right here. So it says, I want to drive to this point over here. And the original Pure Pursuit will, it technically, it's supposed to draw a circle around your vehicle here and then find out where that circle intersects with your path that runs along here. And if you're not close enough to it, it just simply says, okay, uh, since I don't have a path to actually follow, it says the first point is over here. So basically your vehicle is just going to say, in this case, it's going to say turn hard left and drive forward. So it starts off, makes a curve like this until it's pointed at the first point. It should drive a straight line up here. And when it gets close, then gets close to the thing, and you have the concept of the look ahead marker. So the look ahead marker to start with is on top of the first point, and you get close to it, then it jumps ahead by whatever increment you have specified, and then the vehicle follows that, and then it jumps ahead again. It just keeps doing that all the way around. And you can see what happened here was I started off with vehicle pointed north. I started driving, came up like this. It got up here where the point is. The marker started advancing. It followed along. It's doing a pretty good job of staying right on the line. Gets down to this point. It comes around the circle. That's all working. And when it comes around here, then it seems to all fall apart. It starts driving off and starts oscillating. And it might have just kept, if I would have kept driving, it could have been the oscillation would have got bigger and bigger as I went. And then it got to this point, and it didn't quite go around this circle correctly. And it came right here. And my last point is screwed up because I didn't copy the right values in the code. So it should have come, you should have driven to this point and then created a new point out here somewhere that doesn't actually exist, but I just left it off. So whatever the last point was here, it just kind of drove off into the weeds here. And the reason it didn't stop is because I'm running my joystick on my remote control box to control the speed of it. So it doesn't stop until I tell it to. Now, normally, if I had that set up correctly, the velocity would be set to 0. And as the vehicle comes around like this, it comes around when it gets to the point that it thinks it's done, it sets the velocity to 0 and the vehicle just comes to a stop. So that's what it was doing. This is my first attempt after I wrote that new code, and it worked on the simulator, but it does not work on the vehicle. So then I kept thinking, well, what do I do? What do I do next? Let's see how to get out of here like this. Yeah, so then I had the revelation that if I were to slow down the turning speed. So here's an example of when I was experimenting with this several weeks ago, and I decided one of the differences between the simulator and the real vehicle is the simulator, if you tell it to turn to a certain angle, it can just do that immediately because it's a simulated vehicle. And then on the real vehicle, on mine, I've got an RC servo, and it's got a fixed speed on that. So if I say turn from straight forward to hard right, it takes some amount of time to get over there. And I didn't know exactly what that was. So I went back to the simulator, and I'm able to go into, technically, I go into the pure pursuit parameters and say limit the steering angle to whatever number I tell it. So here at the bottom, I see I limited it to 1 radian per second for the steer rate. So when I say turn from straight to full right, it can only turn 1 radian of distance in 1 second. And when I drove it, then instead of being the nice curve that I just had, let's see if that's still here somewhere. So on this one, let's see, how do I do this? Zoom in, come on, zoom in. Okay, do that. Now can I drag that? There we go. Of course, now I forgot what I was saying.
It was about driving different radians per second and the impact of changing that variable head.
Yeah, okay, so I thought it was going to show it right here that it was doing that. Oh no, this is what it should look like. So when I start off, this was not on the simulator. This was on the actual vehicle, and you can see it turns and it goes in a fairly straight line here. And so what it happens is if it turns out if you slow the steering down, it comes around here and it's not where it's supposed to be. So it'll overshoot, and then it goes this way and overshoots and does this. So that's what you can see on this plot here. So it starts off, and it should have turned to hard left right up front here, and then just driven straight up to the point. And you can see it's oscillating back and forth on some line that it has chosen. And then so I thought, well, that shows that the steering is affecting that. So then I went one. How do I get to the next screen here? Like this. So here it is at half the steering rate, so at 0.5 radians per second. So it's a slower steering. You can see it's really exaggerated, and then it's not even trying to follow the path out here. If I slow it down even more, I get this one, and now it's just really a mess. See again, it's trying to drive to this point initially right here, and you can see it's got this big wide loop here, and then it overcorrects so much it comes way out here, and it shouldn't be doing that at all. So that told me at that point the steering angle is affecting it. I didn't know if that was the actual problem, but that's what I was seeing on that. So we come back to this one. So that's what it looked like the first time on the real vehicle. So then how do I get back to here? So this one, what I did was I took the same code that I had, and I determined that, I don't know if that's big enough to read, but I decided that if it is the steering, to speed that up, I can either increase the voltage on my RC servo. It's currently running on 12 volts, and you can technically take it up to 24 volts. And theoretically, it should run at twice the speed if I do that. Or I could replace the servo. I've got that faster one that's got a different gearbox, and it will run 4 times faster just by swapping it out and putting it on there. But as soon as I start doing that, I have to go through all the mechanical stuff and readjust the range pot that is on the servo. And then I also have to recalibrate it. So I have to say, run it all the way to the left and write all the numbers down, run it all the way to the right and write the numbers down and get the center value and write that down and go back through my code and rescale all that stuff. So I figured just changing the voltage was going to be quicker and easier. And the more I thought about it, I thought, well, if I just go out and drive real slow, that will simulate having the steering be faster, because the steering's still going to be the same speed. It's just that if I'm not driving forward as fast, I figured that would indicate whether or not this really is the problem or is a problem. And I'll get back to the how it's changed the voltage in a second here. But so anyway, I did that. I said, okay, I'll just take it out and drive it. So I took it out in the front yard, set it up. Come on. Oh, come on. Okay, over here, I'm going to click on it. There it came up. Okay, so I zoom in on this one. So now I drove around, I started in the same spot and said, I'm just creeping along here. I'm going, basically as slow as I can on the robot. And it's
And
supposed to
this
be,
is physical drive. You're physically driving
yes, this is my physical vehicle and I've got my joystick. So I'm just controlling the forward speed with the joystick. And here's the point that it's initially trying to get to. And you can see it comes up here. It looks like a fairly straight line up to this point, and it kind of trims it off a little bit here, and then starts following down the path, and it's doing a fairly good job. It goes around this one fairly well, comes back here, and now see it didn't on the return path. It's not doing the oscillation here, and it comes around this one. It trimmed this circle a little more than the other one. It comes around here, and it gets right here where it's supposed to stop. And again, I've got that last point screwed up, so it just picks a random whatever the current angle is, it stays at that, and it doesn't stop because I've got I'm still pushing up on the joystick, so it just keeps moving ahead here until it comes to a stop. And this yellow line on here, I did something clever. I just said create another odometry marker, because these red marks are the standard where if you go in and say display odometry, and then you set the length and the size of these arrows or whatever, and then you say how many do you want to keep, and mine set to like 50 or 100. So all these little things, it leaves a trail behind so you can see where you've driven. So this one I came out and I just said apply another odometry marker in RViz, and it's also attached to BaseLink, and I just said make the thing a lot longer and skinnier, and then say just keep one, and that way as I drive around, that just gives you a little pointer so you can see what direction the vehicle is pointed. And then technically, say if I were driving up here and I got that line, and here's the point, you can see which side of that point is the line on as it drives, and that's just another visual indication of what's going on. So anyway, by driving it really slowly, it seemed to work and seemed to follow the path. And so at that point, I'm thinking, well, that maybe will solve all of my problems at that point. Let's see what else is on here. This is just various. So this, when I look at a plot juggler, this is the odometry messages that the thing is publishing while it's driving around. No, actually, this is the odometry message that I'm telling the vehicle to drive on. So this is what's being created by the GPS. The GPS to ODOM program creates this odometry message, and I'm just plotting out. This is where it's telling it to drive, and see, it's again, this looks like the RViz plot of where it was actually driving. So this is telling where it wants to go, and this is the stuff left over from the regular pure pursuit stuff. All the stuff's still in there. I'm just grabbing a different value to control the steering. So you do this. Oh, I switch to a different tab. This is an image, so I can't switch to another tab right now. This they will take, what they do is they take between your base link and a point on the path here. They say create a transform between those two, and this is what falls out of that. This is the X value of the transform, which basically says from the front of the vehicle out to this point, that's this distance, and that's what you see here. So as we start rotating towards, as this, if we have this line sticking out here, as that starts rotating towards the point out here, you can see it's rotating towards that and driving forward. As it does, you can see the X distance. That's the distance from the front of the robot to the point. You can see it's dropping down until we get close to this first point. As soon as we get close to the first point, now you can see the points on the path start incrementing. So as we're trying to get to this point, we get close to it, it goes bang, it jumps here, then it jumps here, it jumps here. So that's what this little sawtooth thing is. You can see the distance, it gets close, then bang, it jumps up another one, and gets close, bang, jumps up another one. So if we could zoom in on that, can I zoom in on that? Let's zoom in one more. Ah, come on. Okay, I'll move real slow this time. Go like this. Go like this. So if you look at this, there should be here, you can kind of see it right here where as the thing moves ahead, it just jumps up as a straight line and then comes down at a curve as we're driving, again, driving towards the thing. And I don't know why it flattens out there, but then all of a sudden it jumps up again. And so it just continues doing that all the way around as we drive around the thing. So the next one down here, can I do this without screwing up the whole screen again? This one is the Y output of that transform. And what that says, so from the robot reference frame, you're looking at base link, and the top one is X, so that's straight out the front of the robot. And this one is the Y, which is out the side of the robot. So this is telling you how far. So if you're comparing the robot reference to the path we're trying to drive to, that's telling you how far to the left or to the right of the robot this point is. So when we start off, we come back over here. When I first start off and we're pointed north, this is like what's this to 9? It's like 3 to 9. This should be about 6 meters from here to here. And we go look at the plot, and it's around. It says like 5.5 meters is how far from. So the robot is pointed this direction. So looking out the left side of the robot, from there to this point, it is about 6 meters, and our plot shows that it's 5.5 meters. And as we start rotating to the left, it starts coming down to the point where it thinks that if we're pointed straight at the point, then there's just a slight difference between essentially the angle drops down. So it's saying from this point out to here, it drops down to close to 0 as we're driving straight towards it. So anyway, that's what that stuff's telling you. And then the other thing, so the off-path error is something that falls out of the pure pursuit, the original pure pursuit code. And it turns out, I think this line is exactly, no, it's not. It takes this pink line here, the sideways offset, and does a calculation and comes out with this. Now it could be that's a direct copy. I think in the code it might just be a direct copy. So again, the off-path error says is this far left or right of the point we're trying to get to. And then the bottom one is after it goes through. This is my calculation I did, where I simply said, take the two angles and take the difference of those two angles and loaded that right into steering angle. And this is what falls out of it. And it's just by looking at it, you can't tell exactly what it's doing, but that is indeed, it's happy. It keeps it happy enough to follow the path. And mine, I think, jitters a little less than what the original pure pursuit stuff does. And one other minor note here, you can see that it's clipping these values. It's supposed to be at, let's see, yeah, point plus, I told it plus or minus 0.5. So that this would actually come up higher and this down here go lower, but it just simply clipped these off at 0.5. So that's just an interesting thing when you're looking at the plots. You can see that's what it's doing. And then here's the speed I was running, and see the average speed is around like 0.2 meters per second. And sometimes this actually drops to 0. If I would drive around and it looked like the steering was doing something more than it should, I would just simply back it off to 0 and let it calm down. And that's what you see, the speed right there drops down. And I guess that's pretty much all we can see on these plots right here. So we'll move on to the next plot. And let's see, that one, that was my real vehicle running my new code. And this is my vehicle running the original pure pursuit code. If we go look at that, it is also working. In fact, right along here, it looks like it's following the path closer on the straight area, straight places. And one interesting thing is this goes all the way around. You can see the original Pure Pursuit code always turns at an angle going up when it drives past the end, and the one on my stuff always drives down. And I'm not sure exactly why it's doing that. And I shouldn't be driving that far anyway. So that was just something interesting that I noticed. And again, this curve on the left looks pretty good. This one, I was going to say this one is trimming it too far, but I guess when I look at it, it's not really much different than what this one is. So anyway, it says the original Pure Pursuit code does work if you drive slow enough. And then either drive slow enough, or my theory is if I speed up my steering, then it will also work. So let's see if I can try this again without trying to blow all the screens away. So again, here's just a plot that's the odometry plot, which is actually the input to the Pure Pursuit. And you can see it looks just like the thing we saw in RViz. And one thing I was looking at, trying to figure out, how smooth is this curve right up front here? And it doesn't really matter, but because it technically from this point where we start up to here, Pure Pursuit's not actually doing anything other than saying there's a point in that direction, let's drive to it. That's all it's doing. So whether it's my code or their code, it just simply says, oh, I got to turn to the left. So it cranks the steering over to a hard left and starts driving forward. So it should make a nice smooth curve. And then once it says it's lined up with this point over here, it should just drive a straight line up there. I think mine was actually maybe a straighter line here. And then again, just the plots. You can see on this one, it's got a slightly different these right here, these little bumps sticking out. That's you can see the little bumps on here. That's what those are. And all of the stuff I ran, I said last meeting that I was getting a jagged location plot. And then if I go into that transform look ahead and change it from what I think it's called ROS time 0, if I change that to ROS time now and put a duration of 1, that seemed to clean that up. So next time I run it, I changed the code, so I'll go see if that fixes that stuff, or is that just simply something Pure Pursuit is doing by interjecting stuff. But otherwise, it looks at the same stuff down here is going on. And here's again the left and right of center. And then here's the important thing down here. Here's my speed as I was driving forward. So on Pure Pursuit, I started up and I'm driving around here. And as I'm driving around, I noticed this one, as I say, it seemed to be, the steering seemed to be jittering more. And occasionally I saw the steering would turn way too far and then come back. And when I saw it doing that, I would just simply drop the speed to 0 and let it calm down so it was pointing in a constant direction. And then I'd start driving forward again. And you can see I did that here and I did that here. And some of these I just simply slowed down enough to make sure it was keeping up with what was going on. But the bottom line is it seemed to either my code or their code. I think here it's got a more, see, when it first starts off, it's got more oscillation there. Can I go back here? Keep in mind what that plot looks like right there. This is see when we first start up, and the off path errors coming here, and this right here I think is still along the as it's driving in the straight line, and you can see the oscillations going on. So let me back up one here. How do I do that? Do that and go back to this one and zoom in. So see on my stuff, I don't have that extra oscillation in there. It just simply turns to the point and drives to it. So I don't have a lot of extra. I don't know if it's their calculations they're doing that, or if I'm getting some jitter because of the GPS is a little bit noisy that confuses its calculations. But it's visually watching the wheels on the thing. Mine seem to be doing a better job of driving directly to the point without extra stuff going on. So that shows that my stuff works and real Pure Pursuit works if you go slow enough. And then down here I had some videos. I don't know if it's worth trying to play these or not. I'll start this one and see while we're sitting here. We'll see if this will play today. Okay, so while I'm sitting here talking, it takes a while before. Oh, I guess it started already. Oh, I started the wrong one. This is the one. this is my code because it's where I forgot, I didn't think to start the video soon enough. So the video, it drove all the way up here and the video started right about here. So you can see how slow I'm driving here. The vehicle is just barely creeping ahead. This should be in real time. And see, here's the look ahead marker. It'll jump from here to here to here. All that's something I screwed up while the video was going. That's not really there. So you can see the look ahead marker will jump ahead and you can see the vehicles following along. Here's that pointer sticking out the front that I was saying. You can see, you can watch that and that shows you the heading of the vehicle while it's driving. So now it gets on a flat line. You can see what the look ahead marker right there is doing. There it jumped, there it jumped, there it jumped. So the vehicle is just trying to follow that marker along to see where that's going. And the important things about this is you can see how fast it's driving, and maybe if you look hard enough, you can see what the response is between the two. So anyway, that's not the one I really wanted to show. Let's go back to this going to work. I wanted to show this one. Well, that's interesting. Start the video over. Okay, play. Make it bigger. So this is the one that there it showed up. This is the one that's the this is the actual pure pursuit code, I think, running on this one. And I started it up and it as soon as pure pursuit starts, it puts the vehicle on there. And when I publish the path, now the whole path shows up here. And that's the first point that it's trying to drive to is right there. So see the vehicle's coming up. Now you'll notice I was gonna say this one has a nice curve to it. I think my stuff does a better curve right there, but you can see so you can see this marker waving back and forth. That's our heading of the vehicle. So as it's not staying on the line, you'll see that moves back and forth, and that's something interesting on RViz you can do just to see what it's doing. And again, you can see how slow I'm moving there, and you can see I'm various times I just come to a complete stop and sit there and wait for it to make sure it catches up before I go ahead. Because I think I only ran this once. I wanted to make sure that, it did a good job of it. And sure enough, it seems to do. The actual pure pursuit stuff seems to work as well as my stuff. Well, no, I still think mine works just a little bit better, and I've got very little testing on it, but the first thing was I was amazed when it worked at all. And then when I went out and slowed everything down and realized it's following the path exactly, that made me real happy too. So anyway, we could sit here for another 5 minutes and let this finish, but I'm not going to. It's just like the other one. It'll come here, come around here, come down there, loop here, and then it'll drive off in this direction instead of this direction when it gets done. But that's irrelevant because it's not supposed to be doing that in the first place. So while it's sitting there running, I'll just ask Al, do you have any questions on what I've been doing here?
Well, a simple question, that arrow that you have sticking out and you did it in RViz, how did you do that?
Well, let's see. We can't see anything outside here. Normally in RViz, you just say turn on odom and you say place, you go out and say add an odometry marker. Oh, maybe that was the same video. It's just that when it started, I was partway into it when it started. So this is exactly the same video we're just watching. So anyway, in RViz, to get these red dots here, you just simply say, I want to see odom, and you say put an odom topic into your list. And then you go to your list and pull it down and say, what topic do you want to connect that to? And I say, I want to connect that to, I just simply have a topic called odom, which is the odometry to baselink topic that's being published. So these red marks are just simply, as the vehicle drives around, that's what you normally get. And I just went into RViz and said, add another odometry marker, and went into topic. And I said, also add that to odom. And then I just simply made it longer and skinnier and said, only keep one of them instead of leaving a trail behind you. Because at this point I could go and say 3 and it'd leave 3 of these markers as it drives around. So you get kind of a like fading type. Like you might even be able to set the fade on these. It seems like the odometry seems to have the most options on what you can do graphically about it. So it's just a convenient way to, so I basically just have 2 odometry markers on here. One's a little short red one that leaves a trail, and then there's a big long yellow one that does not leave a trail. So that's the that was the concept behind that.
Did you happen to run any tests where you changed the look ahead distance to see what the performance change was?
No, I haven't done any tuning on this at all. I've been just running the same thing the whole time. And if we go back to one of these screens here, said what I was running. So right here on all my testing, my GPS on the real vehicle is running at 5 hertz. The GPS on the simulator is running at 10 hertz. And then otherwise, my point spacing on my path is 0.5 meters. My look ahead distance is 1 meter. And on my real vehicle, I'm just manually controlling the speed with the joystick. And on the simulator, I think it's set to 1 meter per second right now. So it's just a constant speed the whole time. But no, I haven't gone through and tried to change the point spacing or the look ahead distance, or the only thing I'm changing right now is the forward velocity, which is one of the variables you can do. And I was just simply, I just manually slowed it way down so I could see if that would make a difference. And then the code I wrote with the angle stuff, I also said, take the error angle and then multiply it by a scale factor and output that. So I do have that scale factor that I can play with. I can make it have more or less effect on the steering angle as it drives around. But I haven't played with that either. It's just got a 1-to-1. I simply said, I've got on my thing here where I've got, here's the vehicle pointed this way, and the point, so it's trying to drive this point. So it's just basically taking the error difference, and as I turn, they just go down until they equal 0, and that means you're driving straight ahead. And if you want to, you can affect that so it turns harder or not as hard, trying to make that curve. And I'm just simply taking that, whatever that error is between those two angles, and shove that right into the steering angle, and that appears to work. I didn't do any extra tuning or anything on that.
Just a comment, I think that was really clever, changing the simulator radians per second and getting it to basically match what you physically were driving with that wavy line a little bit. I mean, that was really, I think, I don't know, validating or whatnot, but I thought that was cool.
What did you think that I did?
When you change the radians per second on steering in the simulator.
Oh, those 3 plots where it showed that one of them kind of worked, one of them got worse, and one got really worse. Is that what you mean?
Mhm.
Yeah, that was just something, because several weeks ago we were saying, what are the differences between the simulator and our real vehicles? And we said, well, the steering speed, the how fast the GPS is publishing, and the vehicle speed, and several other things. So that was just one thing I thought, okay, I'll just go into, because you go into pure pursuit under parameters there, and under the Ackerman section, you can say you can control the Ackerman steering speed. And normally that's set, I think, to 100. So they're saying, turn as fast as it'll go. And I was able to go into there, and that publishes that and goes all the way through the Ackerman command, all the way down to that little module on the simulator, and it will honor that number. So somebody a lot more clever than me thought ahead on that. So by changing that number, I can set how fast that will, on the simulator, how fast that steering will go. And I know for a fact, by looking at that plot that we had, see how quickly can I pull it back up? This one. So if it's set at 1 radian per second, that's not fast enough to make the thing work. And so I know it has to turn faster than that in order to keep it happy. And so that gives me an idea of what I need to do right now. So that brings us around to the point that, so the next step is, my theory is, if I speed up my steering, that will fix my problem. It will be able to drive faster than with a faster steering. So the question is, how do I do that? And I had that list that said,
Go to 24 volts.
Yeah, I could go from 12 volts to 24 volts, or I could mechanically start changing out parts, and then I have to recalibrate everything. And I thought, well, to change the voltage, I've got that 12 volt to 24 volt step up converter that I bought on Amazon. And originally I bought that, it was driving the back motor on the thing, because I didn't think it had enough power. And I got that put on there, and then I realized the thing is now fast enough that if it locks on to full speed and I don't have control, it can be real hard to catch it at that point. So I just took that back off and threw it in a box somewhere. Now, unfortunately, I can't find that. So it's somewhere around here, but I don't know where it is. But if I just bolt that back on and hook that up to the RC servo, now I would just immediately have twice the voltage. And theoretically, steering will be twice as fast. And hopefully I can drive at least twice as fast as what I was doing before. And so I need to do that. I need to get a voltage on there and see if speeding up the steering does indeed take care of the problem. So the other thing I thought of, being really lazy, I thought, well, I've got some extra lead acid batteries laying around. I could just duct tape one of those on there and put the new battery in series with the RC servo, which means it will now have 24 volts. So it's just gonna be a matter of taking the battery, and I need to make one extra jumper lead, I think, and then I just unplug the wire on the servo and plug it into this battery, so it puts it in series with the original power source, and I think that will work. And it just has to run long enough to prove that if I have faster steering, does it actually fix it? So I was going to do that this morning, but I got up late, and then when I looked out, it was raining, so I didn't. I definitely didn't do it this morning. So if I get the time, maybe I'll try it this afternoon if it stops raining, because I can't really move. I can't move on until we prove that is the issue. So.
And then your code for calculating steer angle, what does that look like? Can you pull that up?
Not easily, no.
Okay.
It basically just says at the top of you got that main control loop that's called, when you get an odometry command input, it does a call back to this function called compute velocities. And the first thing they do in there, they say, do a transform lookup between map and base link. And that basically just tells you where you are. That creates your base link position of X, Y, and your heading. And then that comes back as a heading in quaternion. I just take that quaternion and convert that to an angle, just so I have it as a single value. And then somewhere down in the code, it says, downward says, okay, we're actually controlling. I just say, take the difference between the target pose and base link. So I say target pose X minus base link X is dx, and then I say dy is target pose Y minus base link Y. So that gives me my dx and dy. I just simply say take the arctan 2 of dy comma dx, and that is my steering angle. So that gives me the difference between those, and I just load that directly into steering angle with a scale that I'm not using. And that's really all that's doing.
Good deal. I didn't have any other questions.
And other than that, as I'm at the point now, I just have to prove that speeding up the steering will fix it. And then if it does, then I can go through the ordeal of pulling the front end off and swapping out the RC servo, and I have to adjust the range pod and then do all the calibration. And then my steering will automatically be 4 times faster than what it is right now. And then if I get it to steer too fast, I may have problems with it's going to jitter, or I'm going to have oscillations just because I've got too much gain in the system at that point. But I can always add some code that says, I say, go to this angle, and just as it runs through the loop, just have it count down, and just instead of going zip like that, have it go, so it goes tick, 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 tick. So I can control how fast it ticks over to get to that point. So by having something that's blatantly too fast to start with, then it'll be easier to that eliminates that issue. We'll put it that way. So if this is the problem, then it comes back to how do we fix your vehicle? And I think that we just need to go back and look at your servo code for your power steering motor that's doing your steering. We can look at that and figure out, what can we do to make that a little more snappy, a little faster, and still prevent it from damaging anything. So that's gonna take a little bit of exploration on that.
Yeah, I was just pulling up my low-level controller now to see what I have the max power set at. Looks like I got it at 150. I've forgotten what the upper limit is on that.
and talking about all this stuff, as you had pointed out in the past, that if you run your vehicle slower, it seems to do a better job of tracking. I don't think you ever slowed it down as much as I did. And I don't know if you can conveniently do that. Maybe on yours from your joystick, you could run it slower. In which case, do like I did, just go into your low level controller and say, instead of taking the whatever values now, just say take the value coming in from your joystick and load that in, so you could actually just always control the forward speed from your joystick, and that way you could run it slow enough to do what I was doing,
Yeah, I get reasonable
just as an
performance.
experiment.
I get reasonable performance at half a meter a second on the slow side, but I want to increase the upper bounds because 0.75 meters a second with like I think 2 meter look ahead was about the fastest that I could get.
Yeah, and the point of that statement that I made was you had visually you had noticed that as you run it slower, it performs better, and that's kind of what I was thinking about that when I want to do my stuff, and I proved that yes, you just really slow it down, it works very acceptably. So that was my whole point, that you had noticed this in the past and mentioned that. I think more than once you had mentioned that the slower you drive, the better it seems to work.
Yeah, and on the steer, the motor, as you know, the motor controller that I'm using has this power variable, and it looks like I've got it at 150, and 255 looks like the upper limit. So if I want to jam more electrons into it, it's like I have a little bit of space to do that too. So
It does, but you're going to get to the point where your motor's out of control and you have to worry about smashing stuff. So that's why I think we should go through your whole thing, the whole code to do that, and say here's the implications, here's what you can change, here's the implications, here's some other things you can do to control that and affect it. So if we prove that you need to speed up your steering, we can go through and look at that, or you can just crank that number up and hope for the best.
yeah, I'm probably going to live within 0.75 is my upper limit at the moment, or make the look ahead a little longer, because if it's long straight runs, I don't mind having a longer look ahead. So that's were you finished? Because that was a bit of a segue into where I was at.
Yeah, I think I'm done.
Um, so as Jeff mentioned, we're in the testing phase. I was in the mode of wanting to test in a space a little bit bigger than my backyard. And so I got to thinking of how do I do that sort of physically. I mean, up to this point, I've had the laptop on the tractor, which controls everything, but then I've been remoting into that from another computer that physically sits in my garage. And so I'm thinking, well, hey, if I stop remoting into it, what are my other options for starting and stopping this thing? And so, as you no doubt know, once you get out in the yard, you get the sun, you get the glare, and it's a little bit hard to see the screen. And so I've been putzing around with a screen that I think I might be able to see, even with the sun. And it's just, a simple start it, stop it, which location am I at, or if I have to run a new path. And that's, my progress in the last week has been putzing around with this and dealing with, well, I'll just, so the process would be to start this Python script that, generates the screen. I have to physically reset my left and right ODOM in my IMU because I want to make sure that's all clear. I drive to a reference point with it heading in a particular heading. then I press start. This is a new one, right? And it would be start on that screen I just showed you. That would, and when I get RTK fix, then I press, whatever location that I'm at. RTK fix would be this little icon down here on the lower left to say, hey, I've got RTK fix. You're ready to start that location. And so this is what the GUI code looks like at the moment. As soon as I fix my GitHub update issues, that'll be up there on GitHub, but there's nothing clever about this. It's just working through how to use Tinctor to do that. The challenge that I've had is on, I'm going to say rare occasions. I think it's happened to me maybe twice. I press, I effectively start the launch file, and then I run the location, but GPS is off maybe a meter. And I don't like that, especially in my tight fitting backyard, because I'll definitely bang into something. And so I have to stop it, get it back to the reference point, and start again. So that's physically happening. Getting Tinctor to play nice with ROS and starting the launch file from Python. I don't know this stuff all that well, so I'm trying to find the script that does that now. There's a couple of different ways to start a launch file. One is where you start it, and it's inside of effectively the same terminal window as this GUI, and that didn't work. And so now what I'm doing is starting another window and starting the launch file outside of that. So this sub process P open, effectively I'm trying to figure out how to get the clean start stop process and get all of the ROS processes to stop before I start them all again, because I need a clean environment in order to do that. The problem that I was having is I would start and then stop. And then when I went to resubscribe in this function to the fix, topic, I was just trying to find the fix topic to see if I had, RTK status. I couldn't resubscribe. I could execute the command and it wouldn't generate any errors, but it also wouldn't give me any data. So anyway, that's what I'm fighting with at the moment, is how to get this user interface that would run on the laptop of the tractor and hopefully be visible in the sunlight to play nicely. So that's where I'm spending my time at the moment. Questions or comments on any of that?
On that little menu you just showed, you might be better off changing the contrast between the buttons and the background, just so they're not all a light gray when you're trying to read it out in the sun. So like they make the button color itself, make it, and you could even make it like a light green, or say some other color, or just make it a darker, or just make your background a different color from everything else and leave your buttons and the text the same way.
Yeah, that's a good suggestion. I mean, you can't tell it because this is just a picture of it, but when you hover the mouse over, it turns red. So even if I don't press the start, if I just hover the mouse over it, it turns red. And if I hover the mouse over stop, that one changes back and this becomes red. So Yeah, I think any and all of those ideas are good ones about how to make it more visible outdoors.
Okay. One other comment, you said as you're doing your whole startup procedure, you drive over the point you want to start, and for some reason your GPS is off. And then you have to reset that somehow. Why is your GPS off?
What I have found is that even with RTK status, I can be at point A, at 9 a.m. on day one, and with RTK status the next day, it might give a slightly different, not like a gross amount, but it might give a half a meter difference from one day to the next, from one hour to the next. And I'm reminded that the Greenzie guys who do this for a living, they've got a video out there about that's why they have to drive an outward path, because their RTK has some drift in it also. So RTK is great, but there is some over time variations.
Well, I should test that sometime because I don't think mine does that. And now you've got your base station set up in your yard. Is it the base station always in exactly the same spot, or
Yeah, it hasn't moved.
that's the only thing I can think of is that your base station, if your vehicle's now in a different spot, I would think your base station's in a, would have had to move that far, but I don't know. On mine, I just turn it on. I expect it to know where it is, and it seems to. But I haven't actually tested that. So
Yeah, and again, it's not like a really coarse amount, but it's in in, in my yard, I can bump into something if it's a meter off, day one versus day two. About a half a meter is what if somebody said, well, what's that drift? I would say maybe a half a meter periodically.
well, maybe someday somebody needs to look into that because to me, the whole point of RTK is it knows where you are, and it shouldn't have drift associated with that. So a drift or coming back the next day, be in a different spot. So someday we should look into that and see why it's doing that. We can see if it's specific to your particular GPS or if there's something that you're doing that it's not happy with. I don't know. And I should test that to see if mine, make sure mine's not doing that.
Special edition of how it works.
Yep, sorry, I was just getting if you have a minute, sometime you can, oh, come on, paste in there, dog. I just put in chat the Greenzie YouTube where they talk about how they updated their software to detect GPS junk.
I think I might have watched that the first time you mentioned it, and I don't recall. I don't recall much about it, so it just seems like it's pretty short and sweet. And I don't remember if they, what I got out of it, but
Yeah, other than referencing that it's there's certainly no technical details about how they fuse all that data together and track it, but it's just it was like, I don't know, not necessarily validating, but like, yeah, these guys are dealing with it too. So anyway, I was trying to get a GUI so that I can go test in another yard that maybe might be an acre large. So that's my next milestone, is to try to test in a little bit different location.
and if it's a big enough area, stay closer to the middle of it so you don't have anything you can hit. So that'd probably be a reasonable thing right up front to consider.
Absolutely.
How hard is it to move, say, if you're going to go to a different property, because you're going to have to take your base station along and set it up
Yeah.
somewhere, and ideally pick a spot that you can identify the next time you go there. So when you put the base station on the ground, like if there's, say, an intersection of sidewalks, or there just happens to be like some little concrete pad for some reason, you use that as your reference point and put your base station on that. So each time you go there, you can put it back in the same spot and you should be ready to go.
Yeah, you're absolutely correct. So my constraint at the moment would, it's a friend of the family to say, hey, I want to put some sticks in the ground or something to represent where the reference point is for the tractor before starting, and the same sort of thing for the base station. And I need at the moment 110 volts to drive the base station. So those are my constraints at the moment.
Another thing on your base station, if you can remove the antenna, then just simply find a post. If you got a fence or whatever, and it's got a post that's going to be there forever, just stick the antenna on top of that post. So the next time you come back, it's going to be in the same spot. That'd be another thing. So then you put the base station box can go anywhere. It's just that the antenna has to be in that fixed location.
Yeah, that's a good idea. Because I think I have a 20-foot cable on the antenna wire or something, if I need it. At the moment, I've got a short cable, but I've got a 20-foot, I think, cable as well.
Or even you just have a flat surface, say a flat surface of metal, just put a magnet on the bottom of your antenna, so you just stick it on. So if they had like a metal picnic table, or one of those round tables that sits out in the yard that doesn't have the umbrella opened up over top of it, you could just stick it to the metal surface of that, just so you know where on the thing you put that each time.
Yep, great idea.
So once you do that, once you move your base station somewhere else, how complicated is it to say this is my new reference point?
I mean, it's the way the program runs right now is it runs 30 seconds and gathers 30 seconds of data and spits out, where it's at. Averages all that, and
Does it do that every time?
at the moment it does.
You might look into that as why your thing varies from day to day or whatever, because as you turn the thing on and it takes the average, it's not taking an RTK average, it's just saying based on all the conditions, it's going to come up with a number. And from day to day, that's in 30 seconds, that number is going to be different from day to day, I think. So you can either just run it once and just use those numbers every time. Do you have a way to do that where you can just have a constant set of numbers, or does it require it to go through this startup process to declare that's its current location?
Yeah, let me show you the code to make sure I'm communicating clearly. Let's see. Maybe that's over here. So this is the reference point that I set some time ago. And when I set that, I then marked the ground. The 30-second process that I talked about is this script runs each time, I start, and it collects 30 seconds worth of data and summarizes it and compares it to that point. So now that I've clarified what my process is, what gives you concern about that?
You said it runs for 30 seconds and compares it to that. Each time you compare, is it, how close is it when you run this each time?
Like I said, about a half meter, maybe. It's not a bunch.
This is the base station itself is doing this, or is this on your vehicle?
No,
It's
this is a
doing,
script that runs on the tractor when I start it up. Well,
could,
this only starts after I've gotten RTK.
because I'm thinking it goes back to your base station, that when you start up your base station, it's not where it thinks it is. So I don't know how you're getting that to be in the right spot.
I never move it. Well, I mean, in my current yard, I haven't moved my base station.
Okay. And since I don't run my own base station, I just rely on somebody else's service. I haven't really dealt with this stuff, so I don't know exactly what you got to do there. But it just seems like every time you turn on your base station, it comes up in a non-RTK mode because there's no reference. So it has to sit there and watch the data coming in, and that data is going to be kind of wandering around. And in 30 seconds, well, no, again, on your tractor, you're waiting for 30 seconds, but on your base station, somehow it has to know that it's at that 40.34 and 80.12. It has to know that it's at that location. And it could be that it's not coming up with that same value every time you turn it on. But right hand, I can't think how it would know. Is there something in your base station right in the GPS receiver itself where you go out and say you are here in order to make that into a base station? I would think you would have to have something so it knows how to do that.
I would have to go back to the configuration. I believe the way that I set up the base station is that um, I don't think it cares. I don't think there's any, I mean, the base station is just spitting out correction data.
It is, but the correction data is based on where it thinks it is in the world. So I think somewhere along the line, you have to tell it you are at a particular location out in your yard. And then from that, it sends out correction data from that. And that's probably where your extra, half a meter error is coming from, because when you start it up on a particular day, it doesn't know where it's at, or somewhere along the line, you told it where it was, but that's not really what's coming up. So, but anyway, that's something to consider and to look into. I think your base station itself has to know where it is in the world. And sometimes they'll say you can go into your GPS and say, I want to average this location, and you can say average it for an hour or 24 hours if you want, and it'll say you are exactly here on the face of the earth when we ran this test. And then somehow that has to get loaded back in. So every time you turn it on, it knows that is where it's located. So, maybe look into that. If there's some kind of tutorial on setting it up as a base station, see if they talk about putting in your current location, or they might say go through and run that averaging process, and it might automatically load into the thing. But I do think you have to tell the base station where it actually is. And then it generates correction data based on the offset from that it sends out.
Yeah, I was just pulling up my configuration. I have so I have fix set to auto on the base. And if I look, let's see, where are my, I'm just gonna go back into the reference document to see what fix auto, what was the description of that?
But I would think somewhere in the operator's manual, they would have a section telling you how to set this up. Or maybe if these people have a website, they might have tutorials that says, how do you set this up as a base station? And they might go through the steps and say, do this and this and this. And, compare what you're doing to whatever they say to do there. Or you might just go out on the internet and say, search for whatever your brand, whatever your device is, the brand, and say, configure for base station, and see if people will have maybe somebody else has a write-up on how to do that for your particular unit.
Yeah, I mean, I definitely have the manual, I just didn't have it, no, that's just marketing brochure. I'm clicking on something else to see if I can find the manual.
So I was thinking in the original Novotel manuals that they just had a section that says, here's like sample configurations, and says, here's how you configure it for a base station, here's how you configure it for a rover, and they might have had a few more examples. And if your manual has the same kind of thing, since they blatantly copied Novotel, that maybe there's something in there that tells how to do that. And
yeah, yeah, I mean, because the correction logs, the RTCM messages or whatever, yeah, I didn't dream that up. I had to get that from someplace.
all those log statements, that right out of Novotel. Because when you started talking about this, I says, well, do this and this and this, because I knew how the Novotel stuff worked, and that worked exactly the same way on yours. So I know they blatantly copied it. I don't know if they had the permission to do that, or they just did it anyway. Which
We'll not. We are being recorded, so we're not going to comment.
yeah, well, as an end user, we don't care how they got it, but it, as long as the stuff works, that's their problem to deal with that.
Anyway, I'm not getting my hands on the manual here quickly, but
But that's the kind of thing I'd look for, though. Go through and see if you can find a section that says, here's how you configure it as a base station, and then do whatever they tell you there.
yeah, because that's definitely where I got the well, I'll just share my screen again. That's definitely where I got like these statements and the frequency on those. So, and the same with the rover. I mean, I wouldn't. It's been a long time since all that was set up. And I actually haven't turned off my base station in forever. It's plugged into an outdoor outlet, and periodically it will rain, and I bet it's been running for 3 months. But
Well, if you never turn it off, then that might not be the problem, because if it's known where it's been for 3 months, then that it seems like it should be, every day you go to run it, it should be the same. So maybe there's something else. Maybe that's not your problem, but it's something to consider.
anyway, that's where I'm at.
Okay, I guess I got nothing else.